This is my knife throwing robot that can throw knives really well, but like a gymnast with broken legs, it's a miracle if it sticks the landing. That throw took over 2 months of my life to do, and today I'd like to take you on a journey of my rapidly decreasing sanity as I tried to shoot for the stars but ultimately die in a car crash in a Wendy's parking lot, metaphorically speaking. Now this video is technically a part 2, so let me do a quick recap to get you up to speed. And now that we're all caught up, you probably realize the main issue with the robot in part 1 was that it didn't work, which is a slight problem when you want something to work. I also left you hanging off the side of a cliff, so allow me to quickly address the allegations. The story goes I had glued these spacers in to hold the knives better, but they didn't take 38 Special's advice and held on too tightly, so I was cutting them out with an X-Acto knife when it slipped and politely laid the groundwork for 4 stitches to be installed into my finger. Anywho, I had no idea where to begin on fixing this useless clanker, so I decided to let fate take the wheel by throwing a dart at this list of upgrades and starting with wherever it landed. Alright, it looks like the first thing I'll be doing is getting some better knives, because the ones I've been using are, pardon my French here,
Silvus plate?
Sorry, I just started learning. Anyway, these knives are disgusting little cheap pieces of But luckily, when I bought these new cargo shorts, they came with 12 of these Smith & Wesson 150 caliber throwing knives that should actually stick into the target instead of just bouncing off. These knives are much longer and thicker, which should help them fly straighter and hit harder, but just so we're clear here, the smaller knives, which really aren't even small to be honest, can totally satisfy expectations with the right technique. I tried to install these new knives on the robot, which I believe should solve all of my issues, but instead I encountered a major manufacturing defect. If you look very closely, you'll see there are no holes in the back of these new knives, which means I can't put the pin in the knife, making it so I can't put the pin out of the knife to release it. But honestly, this whole rack and pinion release system, pardon my German here, sucked major Wiener, so along with the pin, I won't be using the rack or yun part of the system either. Thinking of redoing this whole system from scratch made me so annoyed that I bought a solenoid to fill the knife releasing void on this broken droid by interfacing with the knife's centroid. Now if you're unfamiliar with a solenoid, that's quite unfortunate for you. It's actually really easy to make one of these. All you need is a Northern European nail with the head ground off, the dumbbell I use for my lateral raises, and some 30-year-old copper wire that's in love with you. Next, wrap the wire around the dumbbell just long enough to realize you own a drill. Then use the drill until you've counted exactly 987 windings. One more or one less winding and it will explode immediately like this one did. 987 windings later, I got my homemade solenoid working and it was way more fun than it had any right to be. It was incredibly weak though compared to the one I bought, so out of pure shame I packed up my entire house, moved across states with some stellar camera work from the wife, and hopefully lost my weak little solenoid during the move. After unpacking everything, I went to crack open a cold one and found a lobotomized carcass in my freezer that I had forgotten all about. Typical Tuesday night, am I right fellas? I hope the rust from the freezer was what we call surface level, which is technical jargon meaning the rust is only on the surface, and hadn't ruined any of my electronics. Oh wait. That is just glue. So I plugged it in to see if it would work, and it exploded everywhere, killing me oh wait, this is the wrong screw. With the bot somewhat working, I teleported back to my old garage and made a new knife holster with the solenoid holding the knife in the center. When the noid gets enough juice, it will sully the plunger and release the knife at the appropriate time, say 11:13 a.m. And after some promising initial testing, I apparated back to the new garage so that I could quantum leap to my old garage because I forgot about this crucial footage of me installing the new knife holsters that you, the viewer, would be totally lost in the story without. Okay, going back to the future that's now the present, I hand soldered the necessary copper to the solenoids and my only goal for this test was to get a knife to release. Which it did, exactly once. The solenoid was too weak to pull back the plunger with just the weight of the knife, so I redesigned the system using the same mechanism turtles use to hide in their shells, but in this scenario the shell is plastic and the turtle is a steel ball that recesses into the shell when this special shaft moves to just the right place. The ball keeps the knife neatly in its holster, and now it should be much easier for the solenoid to retract. It turns out both the solenoid and myself are inadequate at our jobs.
Stupid piece of crap.
But what's a man to do when his designs don't work? Does he just lay down? Does he quit? Does he... So I gave up on YouTube to become a full-time desk assembler, but I found my robot's salvation when I was putting together this E7 Plus standing desk from FlexiSpot, which is today's sponsor. This desk has 2 powerful motors, each responsible for the height of 2 legs. For those following along at home, that's 4 total legs, which makes it twice as sturdy as a 2-legged table. You ever see a horse with 2 legs? There's a reason for that. Anyway, these motors use strong magnetic fields to turn these shafts, which can smoothly raise and lower my 221-pound frame, which some 2-legged desks can barely even hold. In fact, the E7 Plus has a static capacity of 540 pounds and a lifting capacity of up to 440 pounds, so if you've got a patch of grass in your rafters that needs mowed, the E7 Plus is the perfect desk for you. Now, if you put something magnetic up to the motor casing, say a throwing knife, the knife will want to make love to the motor, or whatever a magnetic field makes metal want to do. I don't actually know how all that works. But all this talk of magnets got me thinking of these knife holsters I placed here earlier that can electronically turn on and off a magnetic field which easily sticks to the E7 Plus's sturdy metal legs. The 4-legged design is so sturdy that even at its maximum height of 51.57 inches, the table hardly shakes while I do my jazzercise routine high up above the peasants working out on the floor. 51.57 inches makes the E7 Plus the highest 4-legged standing desk you can buy, but if you flip the 51 around, that makes it a 15, which is the same amount of years these desks are warranted for. I can also use the desk to capture this butter-smooth B-roll of the robot with my corpse in the background because it's currently 200 degrees in my garage. The E7 Plus is also budget-friendly when compared to similar competitors' desks that cost well over $1,000, so if you're in the market for a new desk, I highly recommend getting the E7 Plus. FlexiSpot has special discounts for students, graduates, teachers, medical and military personnel, and are running their 9th anniversary sale where you can get up to 65% off of your order. Use my code YTE7P50 during checkout for an extra $50 off. Click the links down in the description below. Thanks to FlexiSpot for the sponsor. Now back to magnets and stuff. Okay, I first made sure the knives were made out of magnet-friendly metal, and then began assembling the robot's prison for a test throw. At this point, I didn't care where the knives went, as long as they went somewhere that wasn't attached to the robot. The time in the freezer must have given this stupid tin skin dementia and a sassy little attitude, because it forgot to let go of the knives, and then had the audacity to refuse communications with the mothership.
I hate you.
So instead of actually trying to solve the problem, I decided to totally redesign the whole upper half of the robot with some shiny new features that we'll go over in just a second. Alright, let's start with these shiny discs. The original design had the throwing arm motor in a direct drive setup, which led to some angry robot noises when the load was too heavy. So I bought this belt and pulley to increase the motor's torque quadruple-fold. You can tell it's a 4-to-1 gear ratio because after revolving the big gear around the small gear 4 times, one person will realize I'm just padding my video's length and this doesn't actually mean anything. Okay, seriously though, it actually is a 4-to-1 ratio, which you can verify by following the rotations of the black marks on the pulleys. Moving on, this was the old LiDAR system, and much like a white defensive lineman, a bigger and blacker unit has now taken its place. The LiDAR sensor is what the robot uses to detect targets, and LiDAR works by using their eye to emit an infrared beam and then measure how long it takes for the beam to bounce off something and come back, which will give the robot an accurate distance to throw a knife. This new sensor was extremely bright and seemed promising, but it appeared that I received a faulty unit because it was consistently outputting slander about certain objects in the room. And if you whisper to it just right, 100101, it also tells you the strength of the signal, which is a surprise tool that will help us later. Finally, I could talk about how I switched microcontrollers and no longer have a camera, which severely reduces the original scope of the project, but I'm just not going to bring that up and hope everybody forgot about it in the 17 years it took for me to make this part 2. I then assembled the robot by plugging everything in randomly and conducted a quick blessing before I hooked it up for the first time. Miraculously, everything seemed to keep its magical smoke, and the bot even accepted my offering. Yes! And after making sure the throwing arm spun up correctly, it was time for the robot to land 2 perfect bullseyes on its first try. The bot made a valiant effort to eliminate its maker and then itself, but after untangling its umbilical cord and removing the wobble from the code, which I never should have included in the first place, I set it up for some more tests. The release of the first knife was making the robot too excited, and it kept spazzing out before the second knife was released, so I tried putting some weights on it, but much like my engineering career, I had no success.
What What was that?
I then reviewed some motion that was slowed and caught the Wobot in 480p rotating the knives as it threw them, which it knows is illegal in this household. This design doesn't have the necessary hardware to control the rotation of the knife, and my brain doesn't possess the necessary software to design a system that does so. Thus, the knives need to not rotate in air and always have the tip facing the target, so no matter the distance to the target, the knife will stick in it. So I ended up making these, which hold the knife in a dart orientation, and I had no real reason to think these would work other than it just felt right. It was feeling pretty wrong after the second failed attempt, but a knife did stick into the table, which I count as progress. The issue now was the knives felt more attracted to my garage than they did the magnets, so I grabbed my bench power supply to roid up the magnetos and increase the total amount of power supplies on this project to 5. That still didn't work, so I just lowered the speed until I could get this awesome shot of the knives still rotating, which is just so awesome. At first I thought it was the backside of the holster that was causing the evil rotation, so I subtractively manufactured a new knife holster, and you'll never guess what happened next. The knives still rotated. It turns out electromagnets have some serious attachment issues, and even after you try breaking up, they will still hold on until you forcibly remove yourself. And if you come crawling back afterwards, they'll ignore you like there was never any attraction in the first place. It was this residual magnetism that I figured was rotating the knives as they came off the arm. My solenoid was too weak, the electromagnet had a hard time letting go, and my protein shake just exploded all over me. Things were looking dire, but I hate myself just enough that I wasn't ready to give up yet, so as my great-grandmother always said, let's speedrun this hoe. I tried flipping the knives around. I went back to the old holder with the new design. The ESP32 programming cable finally succumbed to its earlier wounds. The robot tried to kill me for a second time this video. The robot tried to kill the ground, which it somehow was the best throw so far. I tried roughing up the magnet and then sandpapering it for more friction force so the knives wouldn't fly off erroneously. But in the end, the only jabroni is me for thinking this would actually work. But hold on a minute, what if I cheated? Up until now, I have been vibe engineering this entire project. Not a single bit of math has been done. I've just been doing what feels right. So I broke out ye olden calculator, experimentally determined the amount of time it took for the knife to rotate, and tried to work backwards from there. I found that the knife rotation speed changes linearly with the arm rotation speed, so if I had a wide enough range of RPMs for the throwing arm, I could theoretically spin the knife at whatever speed I wanted. However, anything below 200 RPMs and the knife stuck on due to residual magnetism, and anything over 250 RPMs and the knife's stuck off due to some made-up force. So there went that idea. I then set the throwing arm to always rotate at 250 RPM, which meant a knife would take about a quarter second to rotate 180 degrees. And once I made sure the LiDAR sensor was reading in a somewhat correct distance, I could calculate a trajectory for the knife using the total time of flight the knife needed to orient itself tip first at the landing point. However, changing the angle of departure also changes the initial angle of the knife, which I first needed to know to get the right angle of departure. I'm sure there is a recursive way to figure this out, but I've never been any good at initial cursive anyway, so there went that idea. There comes a time in every man's life when he realizes his knife-throwing robot's core design is just too flawed to work the way he initially envisioned. But then that same man realizes he's trying to make a knife-throwing robot. No one ever said anything about a knife-sticking robot. From there, I just loaded a simple projectile trajectory equation into the robot, set up the target so that it would be the correct distance for the knife's set rotation, and watched the most beautiful sight I have ever seen. And after changing my pants, the robot had 2 more successful throws, but some of you with eagle eyes may have noticed there's been a second knife being thrown that always misses. Except for that time. This is caused by the imbalance in the arm from the first knife being released, which overpowers the pivot motor, and so the second knife suffers from severe projectile dysfunction. But by golly, we've still got a single knife to work with, so let's test the limits of this thing. First, I tested the precision of the robot by just throwing a bunch of knives at the target and seeing how close the grouping was, which, in all honesty, wasn't even that bad. The math says the maximum range for this robot is 14 feet, so I placed it a baker's fortnight away from the target, target, which should mean the knives will fall short of the cardboard.
Long shot, 3, 2, 1.
Guess I'm not too good at this whole math thing either.
That was beautiful!
It was incredibly cool though to see the robot automatically change its release angle based on the distance of the target, so at least something was working right.
That is so cool.
And finally, remember when I said we could use the strength of the LiDAR sensor reading for something? Well, I plan to do some color detecting with it, but like the other 90% of the robot, I couldn't get that to work either. Alright, if you liked this video and want to directly support the channel, I've been making twice weekly videos on my Patreon that includes behind the scenes on some of my builds and videos, as well as vlogs on quite a variety of topics.
For an engine to run, you need tray things. Air, fuel. Ah, yes, here we go. This is poison oak. You don't generally want to touch this.
So please go to the link below if you are interested.